Chapter 5, Lesson 1. This is our activity with ratios and rates. It's our 5-1 activity, and we're going to do that along with Lesson 1 today. Sounds like a lot, but it goes by quick. So it says work with a partner. We're not going to do that. We're going to do a bunch of this together and move by quickly. Match each description with a verbal rate. Match the verbal rate with the numerical rate. That's what we're going to do first. A and B. What that's talking about is it says take one from this column, where the description is, match it with one in the verbal rate, and then match that as well with the numerical rate. Let's walk through one together. Please circle up your running rate in a 100-meter dash. Now, match that with the verbal rate. Would you describe your running rate? Would the label for your running rate be in dollars per year? Would you say that you're running, how fast you run on the track is in inches per year, meters per second, or pounds per acre? Yep. Circle up meters per second with me. And then match that with the numerical rate. So we're matching this label, this rate, with the same one over here. So we want meters per second. First one is inches per year. This big line means per. So we got inches per year. That doesn't match. Pounds per acre. No, that's not meters per second. Dollars per year. Nope. Aha. Meters per second. Now continue doing that, just part A and B. Would you match each one of these descriptions, the other three, with their verbal rate and then the numerical rate? Since I'm making the video, not here, not walking around in class, I might give you the advice. If you're like me and not really sure the apple orchard or farming things, come back to that one. Do these other two first, and by process of elimination, you should have this one. So I'll give you 20 seconds about, or whatever's, to finish just circling these up. Again, if you get them wrong, that's okay. It's on our process of learning. But please circle on up. So match the fertilization rate with a verbal rate and the numerical rate. Same thing here. I'll let the video run while you finish those up. Just match them on up. We'll fill the blanks in and do part C here in a second. All right, as you're finishing that up here quick, again, if you get them wrong, you don't need to erase them or anything. It's just part of our process of learning here and learning about these descriptions and rates and ratios as we start diving into those. So again, I'm going to come back to this fertilization rate of an apple orchard because it's farming. So again, what I would have done is I would have gone down here. I can kind of figure out how I would describe the average rate for a professional athlete. That would be in dollars per year. And then looking for dollars per year. Well, that's inches, so close. Dollars per year. Aha, down here. Continuing on, again, I'd stick with the average rainfall rate in a rainforest. Pounds per acre. That doesn't sound quite right. I think I'd describe it in inches per year, which is the right answer. And here's inches per year. Which means then by process of elimination, fertilization rate for an apple orchard is going to be pounds per acre, which goes up here as pounds per acre. Now, again, if you kind of mix up some of those, don't worry about erasing it and making it look nice. And of course, you don't have to use different colors like I did. This kind of helps us match things up, especially when there's all these circles and things going on. So from there, then, let's just have a little moment of fun, or at least your math teacher would call it fun with quotes, perhaps. Give a reasonable numerical rate for each description. So don't look it up. Don't ask a partner. Don't ask anybody. Just for fun, what do you think the first one is? What do you think the average rainfall in a rainforest is in inches per year? Just put a number in. Whether you're close or not, we're just putting out numbers there for fun. Same thing. Pounds per acre for apple orchard. Dollars per year for an average athlete. And then your running rate. Let's emphasize that. Your running rate. How fast do you think you'd run a 100-meter dash in meters per second? Let me just give you just like 10 seconds, maybe 20 again, just to put a number in. If you have no idea, just still, put down a guess just for fun as we look at just talking about rates. Again, those were just numbers to put on in. If you have no idea, don't worry about it. Just put something on in just for fun, so that way you took a guess, just whatever you thought. And if you're completely wrong, do not worry about it, because some of them are tricky, like this one here. When we talk about average rainfall, well, it depends on which rainforest you're in. When you look it up, it says that they can get anywhere from 50 to 260 inches per year, which is a lot. When you look at that, 260 inches of rain a year. Well, when you take 260 and you divide that by 12 inches, because it's 12 inches per foot, that's going to get you quite a few feet of rain. 21 feet of rain possible, almost 22 feet. So if you think about that, that's some places get 2 basketball hoops on top of each other amount of rain in a year for the rainforest. Again, we could talk about that in science. Of course, the rainforest, where not all of that hits the ground, a lot of that stays up in the trees and all that, but that's neither here nor there. Just a fun number, so if you were anywhere in there, good job. If you weren't, good job. Thank you for putting down a guess. We're just talking about learning. This one here, oofta me. I tell you what, I should really ask a farmer about that, because depends on where you're at and what you're doing, what you're putting on. So when I was looking it up one year, it looks like you could put down 120 pounds per acre if you're putting down nitrogen, but if you're putting down phosphorus, it'd be 150. And then, of course, there was some potash and things like that. So that if you're putting down that, well, that was 265 pounds of potash per acre. And what does all that mean? Well, they're just different type of fertilizers. But again, now this is where in class we'd probably take a longer detour here and talk about average salary for a professional athlete. The trouble becomes is, what athlete or what sport are you thinking about? Oftentimes, perhaps we think right away to football. We think about what a football player might make, but when we look at those, we've got average football player can make anywheres, well, they're making about $860,000 on average here in about 2021, 2022. But of course, that's $860,000 a year on average. You got some athletes, some quarterbacks making $12, $14 million up to $40 million. And that's without all of their bonuses or merch or commercials and things. You've got other players when we talk football, like the kickers. The punters can be anywhere from $2.5 million for 2022 for Greg Joseph and the Vikings to $4 million is what I saw for Mason Crosby with the Packers. And again, depending on who you're looking at, we got different ones. We could jump to a different sport. You got hockey. Well, if you're thinking about hockey, the average hockey salary is $3.5 million per year. That's just their salary, although their top, though, according to 2022, is $12.5 million per year for an average. So that's a significant difference there. You can see it a little bit higher or lower. We can talk about soccer, whether the World Cup or whatever. The average American professional soccer athlete makes about $70,000. It's higher with that, about $380,000 for the top person. But when we talk American soccer professional, it's about $70,000. Well, if you want to talk European soccer, average Manchester United makes about $7 million, and you got others at $5-6 million. And then, of course, at this time in 2022, I just looked up, Messi, and there's tons of others. So let's not get too sidetracked on all the different people we could be talking about. But right now, Messi's making $41 million a year to play soccer, and then that all depends. I looked up the average race car driver, or whatever sport you're thinking of. That can change here, what we're looking at, as we talk about what they make per year. And of course, are you including all their bonuses, all of their merchandise, all the commercials, all their endorsements? And then down here, what do you think your running rate is? Well, looking it up very fast, Usain Bolt is still the fastest person to run a race. He ran a 100-meter dash just under 10 seconds. So he's got a speed then of 10.44, 10 and 44 hundredths meters per second at his top speed. So if you have anything above that, you are faster than the fastest person in real life. But again, whether you had it right or wrong, don't worry about it. Don't erase it. You put on a guess, and that's all I asked. That's all I was wanting you to do, to be open for a challenge or the opportunity to take a guess at how much that is. Now again, 10.44, if you're in my classroom here in 2022, or at least in room 226, that's from the south wall out my classroom door 3 feet. So if you stepped out of my door 3 more feet, that's how fast Usain Bolt goes every second on his top speed. He is cruising that fast. It said online if you want to transfer that, it's about 37.5 miles per hour at his top speed. But that being said, let's continue on here. It says work with a partner. We're not going to do that. If you could please do me a favor, this is called a complex fraction. There's a big fraction line. Put a line right through here. That is going to help us out. It says to rewrite, so that's what we're going to end up doing here. We're going to rewrite this. So whatever's on top, write that down first. So half. And this big line means to divide. And then we're going to divide by the bottom. Please note, we have a fraction somewhere in here, so we don't divide by fractions. We don't divide with fractions, whether you learn keep, change, flip, KCF or KFC, or of course multiply by the reciprocal. Please remember, 4 is a fraction, is 4 over 1. So reciprocate that. Flip that. We get 1 over 8. Same thing. We're going to see this again. Hopefully we've seen it before, but if not, here we go and see complex fractions, where there's a fraction in a fraction, or there's 2 fractions inside a fraction. Looks complex, but technically all we need to do is rewrite it. So it sounds silly, but which of these lines is the bigger line? This line here on top or this second line down here? Since the bigger line is the one on top, could you emphasize that quick, please, in front of you? Doing so, please note, whatever's on top, write that first. Then put the dividing by symbol and divide by whatever's here on the bottom. We don't divide with fractions. We don't divide by fractions. So we're going to keep that first one the same and switch it to multiplying by the reciprocal. So please flip it. Top times the top and the bottom times the bottom. Get you 8 6. We'll simplify that. 6 goes into 8 one time. 1 times 6 is 6. Take that away. And we got 1 and 2 6, or 1 and 1/3. That'll work for us, unless they ask us to keep it as a ratio, in which case we would leave it as 2 numbers separated by division. And that works. Go ahead and turn to the next page. Here on the back, we got a couple more, but for time's sake, I'm just going to bypass one of them. Here's a complex fraction. It has a fraction and a fraction in a fraction. Oh my, don't panic. Which line is the longest? The top, the middle, the bottom. It sounds like a silly question, but first, second, or third, which one's the longest? Since the second is the longest, please emphasize that nicely. Probably shouldn't have crossed out the 3, but oh well. Whatever's on top, write that first, because it's 3/8 cup sugar per 3/5 cup flour, or it's 3/8 divided by that bottom of 3/5. We don't divide with fractions or by fractions, so you're going to keep the first one the same. And we're going to switch it to multiplying by the reciprocal. So flip it. From there, off we go. Cross-canceling these guys. 3 divided by 3 is 1. 3 divided by 3 is 1. You could have multiplied across the top and told me it's 15 over 24 and simplify, but by doing this, you now get 5 over 8, which is in simplest form. For time's sake, I'm going to bypass that guy. Please note, activity 3, we're going to talk about this. It says identify the rate in this problem. A communication satellite orbits travels about 18 miles every 4 seconds. That is the rate. 18 miles every, or I'm going to use the word per, 4 seconds. As a quick side note, we're going to talk about it over and over and over again in this chapter. Usually, to have things sound right, if there's money involved, we're going to list it or say that first. And if time is involved, it goes second. Just like here, how this time, seconds, went second or was listed the second thing, so 18 miles per 4 seconds. We could flip it around and say 4 seconds per 18 miles, but more often the seconds helps us at the end to sound more normal. So you can recall to use a ratio table to find equivalent rates and ratios. So let's complete this. In 4 seconds, it travels 18 miles. Well then, let's continue on. If it's going if every 4 seconds it goes 18 miles, well, let's go another 4 seconds. Well, that means then how many more miles have we gone? The rate would be every 4 seconds we're going 18 more miles, so add 18 more on. We get 36, so that's an equivalent ratio there, 8 over 36. Same thing, what if we went another 4 seconds? How far would it be? Mental math, calculator approved. We'd go another 18, so you're at 54. What about going another 4 seconds? We'd go another 18 miles. What about another 4 seconds? We'd go another 18 miles. Notice again, everything is changing the same. Across the top, it's always 4 seconds. Across the bottom, it's always 18 miles, because that is our rate that we were told. It's 18 miles per 4 seconds. So then, if you were going to figure out how to find out the speed of the satellite in minutes, how could you do that? Well, here, it says that you could do this using the table. So, well, if you're going to use that, if you want to figure out how fast it's going per second, per minute, how many seconds are in a minute? Since there are 60 seconds in a minute, we need to keep taking this table all the way out to 60. That's one method. You can do that. Same thing, miles per hour, we have to go way out there on this table. But another thing we can do is we can just use that rate. So as we talked about up here, if there's a time, it usually goes on the bottom. So I'm going to put that 4 seconds on the bottom. Here on the top then, put down that 18 miles. That's a lovely rate, and if you divide those out, mental math or a calculator, it gets you 4.5. And then use the labels on top. Miles. The big line means per. Everybody say per. So this big line means per. And then we got that bottom label. Second. So we could use this. And now that you know that, could you find out how fast it goes in a minute? Could you take that times 60? Yeah, you could. Could you figure out how fast it's going per hour? Could you take that times 60 again, since there's 60 minutes in an hour? Yes, you could. So I technically already told us the answer here. How far does the satellite travel in 1 second? Well, you can do the math to find out it's 4.5 seconds. You could have gone backwards as well up here. Going backwards 4, well, that wouldn't have worked, but you could have cut this in half. That would have been 2. Cut this in half, and 9. It's a way to use a ratio table, right? Well, then cut that in half. Half of 2 is 1. Half of 9 is 4.5. There's a way to make a ratio table to find it. Then again, half a second, you could do the math. You could cut this in half. Or again, by using a ratio table, cut it in half up here to figure out how fast it's going. Now this next page, we're going to go over very quickly because on our assignment we've got some like this, but they're not in our notes. It says work with a partner. Don't worry about that. We're going to go very, very fast. So if you know that you're got 10 gallons in your vehicle, and you know that your MPG, your miles per gallon, your fuel economy is 22 miles per gallon, how far can you go? Well, when you hear me ask that, many times you can tell me the answer right away, but when we see it written in front of us, sometimes we get confused because there's so many things here. So please, write this as a fraction, 10 over 1. From there then, notice our fraction dance, we're going to multiply across the top and the bottom, but let's cross cancel. Anything between the 1 and 22? Nope. The 10 and down here? Nope. But notice something important. There's a gallon on top and a gallon on the bottom. Please cross those off. So then when we multiply across the top, that gets us 220 miles. Along the bottom, 1 times 1. So your answer is 220 miles. Mr. Wells already knew that. Good. We can do that. The trick is when we see things like this, we've got to be very careful. So down here then, we've got 7.5 pounds times $3 per half pound. So that one can be kind of interesting. I'm going to come back to that one in a second. Let's jump over to part C. If you travel half a second, but you can go 30 feet squared per second, what do we get? Well, again, looks interesting, but saving time, put a 1 down here with the second. Notice we have a fraction, so you can take the top times the top and the bottom times the bottom if you want to get 30 over 2. Or you could cross-cancel the numbers. So from there, get 15 on the top, 1 on the bottom. Please note, though, when we're cross-canceling today, we're going to look at cross-canceling labels as well. Cross out that second. Cross out this second. So we get 15 divided by 1. Well, that's 15. What's the only label that's left? Feet squared. Well, that's why our answer is 15 feet squared. Just like over here on part A, probably from context could figure out what it is. If not, when we see it in front of us and don't have any context or someone explaining it, when the labels cancel, you're left with just miles, which is why it's 220 miles. This guy looks kind of interesting, but we'll just do what we've done before. Take the top times the top, get you 21. What's the bottom times the bottom? What's 2 times half? What's half of 2? 1. Nice. What's 21? Divided by 1. It's our 21, but now notice again, we need a label, and it is important as we start this chapter to start watching for which label is correct, which one we need. So it's either pounds or dollars. Don't make a guess. Take a look. This pound is on top, this pound is on bottom, so cross them off. The only label left is that dollar, so you're left with $21.